In this assignment, I worked on image classification using the CIFAR-10 dataset. The goal was to analyze overfitting and apply different techniques to reduce it. In CIFAR-10 contains 6,000 images across 10 classes. I used this dataset to train a convolutional neural network. So, so the data is normalized by dividing pixel values. This improves training stability and performance. The dataset is splitting into training, validation, and test sets. This helps evaluate performance and detect overfitting. So from the so from the graph, training accuracy reaches around 93%, while validation accuracy stays around 41%. This large gap indicates the model memorizes training data but does not generalize well. So for model 2, to reduce overfitting, I applied dropout and L2 regularization. Dropout randomly disables neurons, and L2 penalizes large weights. The gap between training and validation accuracy is reduced, which shows improved generalization. I also applied data augmentation, which creates variation of images such as rotation and flipping. This increases dataset diversity and helps reduce overfitting further. The validation accuracy improves and become more stable. Comparing all models, the overfitting model had very high training accuracy but poor validation accuracy. The regularized model reduced overfitting. The augmented model performed best with the highest validation accuracy and smartest gap. And the models were trained for around 20 uploads. 20 uploads. After this point, validation accuracy stopped improving, in, indicating that further training would lead to overfitting. And finally, the model was evaluated on the test dataset. The test accuracy is around 40%, showing reasonable generalization. In conclusion, overfitting was successfully demonstrated and reduced using dropout, L2 regularization, and data augmentation. These techniques improves model performance and generalization.